Feel free to correct me anytime. Yes, Priscilla?
This is 30x, is equal to 5y minus 6, and then below it 9x is equal to -2 times 4y.
This was -2. Very good. Okay, so
It's like a system question, it's not like number interval.
so do we have a number for this problem?
It is number 9 and 5.1.
Number 9 and 5.1. Thank you. So first of all, it's not arranged in the correct order, so I will have to rearrange it as 3x minus 5y equals -6. Do we agree with this step? Okay. Then the same thing with 9x plus 4y equals -2. I think the best thing to do is to eliminate x, multiplying the first equation, both sides, everything, by -3. So then we get -9x plus 15y equals 18. So -9x plus 15y equals 18. And then 9x plus 4y equals -2. 19y equals 16, and there is nothing we can do, is 16 over 19. So this is good, but it's not good enough. We have to determine x. So let's go back anywhere. It doesn't matter. Let's say we go back to the first equation and replace y by 16 over 19. So this will be 3x equals 5 multiplied by 16 over 19 minus 6. Is this clear so far? Everyone? Okay, so remember this is 5 over 1, so this is 3x equals 80 over 19. Minus, I'm sorry?
Did you cross multiply?
I only multiplied this first. I have to multiply before I subtract. So minus 6. So this is 3x equals 80 minus 19 times 6 divided by 19. So then we have 3x equals, so how much is 80 minus 19 times 6? If you have it, give it to me. 80 minus 19 times 6? Negative what?
60.
Negative 460?
Did I calculate it wrong?
I'm not sure. I don't disagree or don't agree.
Negative 34.
Okay. Negative 34? Very good. So then x equals negative 34 divided by 3 times 8 times 19. So it's 57.
Oh, oops, I put 9 instead of -6.
Oh, that's okay. No problem. So the solution appears to be negative 34 over 57 and 16 divided by 19. And we have to go back and check. Any questions on this problem?
Where you had 3x, 82 over 19, minus 6. Before that, so you cross multiplied the 5 through 19.
So 5 is over 1. 5 times 16 is this. 1 times 19 is this. I can't say I'm cross multiplying. That's I can't say yes to that.
Okay, so 5 times 6.
So I'm multiplying the numerators and I'm multiplying the denominators, and I get this. And then I change, the subtraction is, I have to find the least common denominator. Yes,
Why do you subtract 19 and the one underneath that?
say it again.
How can you subtract 19 from the top? Where do you get that from?
This one here.
Yeah, we're gonna read it first. Yeah.
Okay. So we don't remember how to add and subtract fractions. Okay. So 2 over 5 minus 1 means 5. I multiply the top by 5. 2 minus 5, which is negative 3 over 5. So 80 over 19 minus 6 is the same procedure. I have to multiply 6. We did this in rational equations in chapter 1. So we have 80 minus 6 times 19 over 19. In the same way, I subtract 1 from 2/5.
Okay, I guess I just probably you like right with the first one, not like you usually don't do it.
Oh, because I didn't calculate. I still have to calculate. So Is this better?
Yeah, that's better. Yeah.
Can you go back to the last page?
Sure. Is this okay?
I mean, I'm just gonna have to look over it.
Which part is not clear?
After, like, the 3x's and 18 after that it's
This one here?
that's the one above it.
How we got this?
Yeah.
5 times 16 over 1 times 19. I just have to copy what I have. So I have 3x on the left-hand side, and I copy it. I have 5 times whatever y I got. 5 times whatever y I got. It's this. We just determined it, 16 over 19. And then I have to copy minus 6. So now if you don't like this way, the way I do, or I add and subtract fractions, forget about it. Just tell me what you get. Just add, subtract, multiply first 5 over 1 by 16 over 9, and then subtract 6, and then you'd give me the answer, whatever it is. Yes?
Also, if when you complete the calculator is giving the same thing as well.
That's fine. But
Like,
don't change it into an approximation though.
no, I know, and then if you get that, you can just put math and then convert it to fractions.
That's fine too.
So
Whatever
that way it doesn't
whatever
make it
works.
so easy.
But by now we should know how to add fractions and subtract fractions. I don't think we should have difficulties with this, but maybe I didn't explain it thoroughly enough. So I cannot add fractions that do not have the same denominator. So I have to change 6 over 1 into something over 19. So I have to multiply top and bottom by 19. And we did that in chapter 1.
Okay.
So
For the,
So it's 6 times 19 over 1 times 19, so I can have the same denominator. So then I perform these operations. I cannot simplify. I have to perform these operations, and I get negative 34. And then I divide both sides by 3, or I say I multiply both sides by 1/3. And that's how we get this. Is this okay?
yeah.
Again, do not look at, if you have a different method of adding fractions, forget about mine. You do not have to switch to my method. Add those fractions, subtract them the way you like. But you will end up with negative 34 over 57 with minus in front, guaranteed.
Okay.
But you don't have to follow my steps if anything is confusing. Because this is not really part of this course, right? This is part of the first steps in arithmetic. So you don't have to look at this. Just calculate this and divide by 3, the way you like to do it. It doesn't matter really. Any method is acceptable here.
Okay. And then after you got the negative 34 over 19, you multiply that by
I have to remove this. The only chance I have to remove this is either divide by 3 or multiply both sides by 1/3. Because I have to solve for x. So, but x has a 3 in front. So I have no choice. I have to remove the 3. But the only way I can remove it is either divide both sides by 3 or multiply by 1/3. Multiplication by 1/3 gives us a 1 here. But then I have 1 times negative 34 and 19 times 3. If you want to say it's divided by 3, then you will have to multiply by 1/3 anyway. So when we deal with fractions, it's better if we consider that we multiply both sides by 1/3, because there is a fraction here. But it really doesn't matter. You will get the same answer if you divide. Any questions? Sorry if that step was confusing. Just don't look at, if you have your own method, use your own method on adding fractions. You do not have to use mine. Anything else? Anything else? Is there anything else you tried? Anything else you would like to see before we look at 2 more sections from this chapter? Not this chapter. 2 more sections from the course, actually. So we are looking at 6.1. Anything else? Yes, please.
But like,
Yes,
so
any.
that's the right answer, and I put it in, and it said that it was wrong, and then it, as the correct answer, it put the, I don't know, the same answer I put in, it's saying that it's wrong. But it's saying it's the correct answer.
Maybe you forgot to put a comma or something.
No, I put it
Oh, sorry.
That system is weird.
So correct answer, we could do 34.
It's weird.
I don't know.
Oh, you put 9 instead of 19.
Yeah.
Okay, that's fine.
At least I know.
That's fine. Okay. So in chapter 6, we only look at 6.1. It's a method like substitution and elimination. It's a third type. It's called matrix solutions to systems. I would like to directly call it Gauss-Jordan method. They both developed this maybe independently. I don't want to say something and then have to come back and correct it. But it's a third method of solving systems. The first one we looked at was substitution. The second one was elimination. And this is the third one. Okay. Before I go into the method and I'll show you the steps, I have to warn you that the first problem that we work on is going to take like forever. But the next and the next and the next will be much easier. So please be patient. And stop me anytime if you don't understand something. So I'm on page 631, and I would like to choose a system, let's say 22 on page 631. I'm copying the system so I can put the book away. This is a 3 by 3. By 3 by 3, we mean 3 equations in 3 variables. So x minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y minus 2z equals negative 4. I'll check my system in a second, just make sure that I copied it correctly. So x minus 2y minus z equals 2, correct. 2x minus y plus z equals 4, correct. Negative x plus y minus 2z equals negative 4, correct. Okay, now I can put the book away. Okay, few things we have to establish here. The first thing that we need to establish is what it's called the matrix of the system.
So just so it's clear, when we see a problem like this, we cannot use
Gaussian elimination.
as a decision of that.
You could, I accept it, but this is the full method.
Okay.
Gaussian elimination stops you in the middle.
Okay.
And then you have to do some algebra. Yeah, I'm fine. As long as you know one of the method, one or the other, I'm fine.
Okay.
But I'm going to show the full method. And you decide. So the matrix of the system, first of all, what is a matrix? It's simply an array of numbers. How does it look? When we talk about the matrix of the system, we really talk about the coefficient matrix. That's what I meant. Coefficient matrix. So for this particular system, here's how it will look like. So these look like brackets. You could say that. And on columns or rows, it doesn't matter, we will have a column of coefficients of x. 1, 2, negative 1. 1, 2, negative 1. We will have a column with coefficients of y. Negative 2, negative 1, 1. And we will have a column with coefficients for z, negative 1, 1, negative 2. So this is the preliminary situation, preliminary step. This is denoted by A, uppercase A. And this is the matrix with coefficients of x. and y, and z. The coefficient matrix of the system. Is that okay? Okay. There is something called the augmented matrix.
Is that what this is?
No.
Oh, I saw
The-
the name, sorry.
Sorry about that. So no. So this is the matrix of the coefficients, but now we're going to talk about the augmented matrix. So see a vertical bar, a lowercase b, in brackets. What does this mean? It's the same matrix, A from before, with the bar towards the end of it, towards the right-hand side. I copy the matrix, 1, -2, -1, 2, -1, 1, -1, 1, -2. But now I will augment it by the free terms, 2, 4, -4. 2, 4, -4. And now let's talk about the purpose of the method. And then I have to explain one more thing, and then we'll start the method. Okay. So I would like to perform some operations. And I'll talk about the operations in a minute. 3 possible operations on the augmented matrix until it looks like this. But you can say, you can ask, what are those 3 operations? I haven't talked about them yet. I will in a minute. So I'm allowed to only perform 3 operations on this matrix, the augmented matrix, but this is my dream. My dream is that at the very end, I will get this. Give me 3 numbers. Any numbers you can think of.
1,
1,
2, 3.
very good. Of course, this is not the solution. I would be surprised if this is the solution, right? I would be surprised that we will get at the end like this, but with this matrix. But if we do, can anyone identify x?
1,
Exactly. Can anyone identify y?
0.
Oh, up.
Oh. And the top one?
Oh, 2. Exactly. Can anyone identify z?
3.
That's it. But only if I manage to make sure that at some point in time when I'm done, all these entries are 0, but only the diagonal entries are 1. And only 1. And then I know x plus 0y plus 0z equals 1, which means x equals 1. 0x plus y plus z, 0z equals 2, which means y equals 2. 0x plus 0y plus 1z equals 3, which makes z equals 3. Yes, Crystal?
I was going to ask you to repeat something that you had said.
Yes.
Now,
Yes,
now
of course.
I forgot what you had said.
Okay, so
It's something about like, you say diagonal?
yes. So you see that is the matrix. I want it to look like this,
Okay.
which means all entries are 0 except the diagonal entries, which are all 1, nothing else but 1. And then I'm very clear. It's very clear. X is 1, y is 2, z is 3. This is my dream. I need to change that into this. But there are a lot of steps in between. Now the question is, what are those 3 possible operations? I'm not allowed to do whatever I want. I'm only allowed to do 3 possible operations. And let's talk about those operations, and then we'll apply them. Yes?
So in order for the matrix to work, the first format needs to be x, y, z, correct?
Of course, I forgot to mention that. My apologies. The system has to be x in the same order. X below x, y, like we did before for all the other systems. 2 by 2.
We've done the same terms in each
Absolutely, yes. Otherwise, I will not be able to change it into augmented matrix. Absolutely, my apology. So x has to be below x, y below y, terms y the terms with y one under the other, the terms with z one on the other, the equal symbol one under the other, and the free term on the left-hand side, on your right-hand side.
If the y was missing, could they put like a placeholder of like 0y?
If anything is missing, you have to put 0. There are no variables in this matrix, only coefficients.
Right.
If a term is missing, you cannot write 0y. You would have to
Right.
write
Oh, I
0.
just meant like in the equation, you would think of it as 0y, and then just pull that 0 down.
Exactly. Okay. Yes. Yes. Very good. Great questions. Thank you. Okay. So now let's talk about those 3 possible operations, and then let's see step by step how we change this into this, and that will be the end of chapter 6. That's the only thing we do here. Just it's not good. Okay. Ready? A few minutes ago, we worked on a problem. So let's go back to it for a moment. Here was our problem, right? 3x minus 5y equals negative 6, and 9x plus 4y equals negative 2. Right? A few minutes ago, we worked on this problem. So what did we do at some point in time? We multiplied this row or equation by negative 3. Here it is. And we added it to the second equation. And we got this. One more time, because this is one of the allowed operations. So this is really the most difficult one to understand. So one more time, let's go back to this problem. We multiplied this row by negative 3, and we added the result to another equation. Please keep that in mind. Okay, so let's go back to the first operation that is allowed in an augmented matrix. Number 1. Swap rows. Now, if you ask me when will I do that, I'll show you when and why.
And this is allowed.
It is allowed.
Okay.
This is one of the 3 operations that are allowed. So here's my question to you. Coming back to our augmented matrix, for whatever reason, let's say I want to make this row the 3rd row and put this row as the 2nd row. Do you think that the final solution will change?
Yeah.
Absolutely not. Because I have equation 1, equation 2, and equation 3. If I present the system equation 3, equation 2, and equation 1, the solutions will not change. It's like I'm moving something from my right pocket into my left pocket. I still have it. That's all. So I can swap rows. It doesn't matter. So if the system looks like this, 1, 2, 3, or looks like 1, 2, 3, or looks like 1, 2, 3, it's the same system. I will have the same solutions. It doesn't matter. The order of equations doesn't matter. One more time. Going back to our previous problem. Do you think that if I swap these 2 and I consider this one the first equation and this one the second one, do you think that the final solution will change?
No.
No. Doesn't matter. The order is not important. Good. So then, that's our first step. First allowed operation. Second allowed operation is multiply or divide by, a non-zero number. Multiply and divide any row. So let's come back.
Oh, I have a question. So for the swap rows, if we put out the same answer, why would we swap in the first place?
It's a very good question. You have to wait to see. Just I already said I did not explain when is that allowed. I mean, when is that necessary? It is allowed any time, but when is really necessary? Why would I do that? Very good question. In a minute I will explain. Good. So multiply or divide any row by a non-zero number, like we did here. We multiplied this row both sides by -3. That's always allowed. It's not going to change anything. Okay. And the last one is the one we just talked about. Let's put it in writing. Multiply or divide, although I would like to put divide in parentheses, only because it's rare that I will multiply both sides by 1/3, which is basically a division. So I'm going to say multiply any row by a non-zero, we cannot multiply by zero, zero number, and add the result to another row. So let's understand the difference between operation 2 and operation 3. In operation 2, I only divide or multiply, and you will see when. So I only divide or multiply by -3. But in operation 3, that's more complex. I am multiplying this row by -3 and immediately add the answer to a second row, or the third row, or any row. So this is more complex. Yes?
But when we multiply and divide the rows and we add the rows, we adding all 3 rows?
No. Very good question. Excellent. It depends on the purpose. It depends on the purpose.
Oh, okay.
You'll see in a minute. But very good questions. Awesome. Okay, now here is the sequence of steps. I can use these 3, but only if I accomplish the following.
Wait, about one more question. So when I multiply one row and I add them to the second row, can I and then I need to get the third row to be 0, 1, 0, 0, 1. So can I just multiply the second row by that number so I can
Of course.
add the other
It's
one?
possible, but we're not going to do that. So I can use these steps, or these operations, I should say. I can use these operations in any order I need to, as long as I accomplish the sequence of steps that no one can deviate from. The sequence of steps that I'm going to present, no one can deviate from. You will not get the answer if you do. So the first step is the 1 in the upper left corner. Then the 0 underneath, and the 0 underneath. If it's a 3 by 3. If it's a 4 by 4, then I'll have to continue. Another 0, another 0. We're not going to illustrate with more than a 3 by 3. This is good enough. The next step would be 1 in the middle of the second column, followed by the corresponding zeros. And the last step will be 1 at the bottom of the third column, followed by the zeros. And whatever, whatever, whatever. If you deviate from this sequence, you will not get the answer. So one more time. 1 will help us get the corresponding zeros. Then 1 will help us get the corresponding zeros. And finally, 1 will help us get the corresponding zeros. One more time. 1 will help us get the corresponding zeros. 1 will help us get the corresponding zeros. And 1 will help us get the corresponding zeros. No deviation from the steps. Okay. As I mentioned, and I promised, a lot of talk. Okay, now I'm ready to copy the augmented matrix. And let's see how we proceed. So here's the augmented matrix. Ready? We do not write the equal symbol between matrices. They are not equal. So we only write an arrow, not the equal symbol. So this is the augmented matrix of the system. And I know that I have to start with the corresponding 1 in the upper left column and row. Lucky me, I already have it. I don't have to do anything about it. However, what if I have here, let's say, a 4? I could, that's one option, excellent. But the other option is to swap the row. Put this row at the top, put the row with the 4 at the bottom, and just multiply this row by -1. That would be an example in which I would swap rows.
So we don't have to.
We don't have to in this case.
So you have to swap row, you would
Yes. I will move this row as the third one, and I will move this row as the first one.
and then multiply it by whatever number is left.
Whatever I need. Yeah. Very good. Okay, now please tell me how on earth I could get a 0 here and a 0 here, keeping in mind that I have to use the 1. So I will have to multiply row 1 by something and add it to row 2, and I will multiply row 1 by something and add it to row 3. But the question is, what am I multiplying by? I want to eliminate a 2.
So you want to do it.
I want to multiply the first row by -2. Great job. Now I want to eliminate also in the same step, I want to eliminate the -1. What do I multiply 1 by to add it here?
Negative.
If I multiply by -1, -1 times -1 will be -1.
Then
Just nothing.
Oh,
Just
right.
nothing, basically.
Okay.
Correct. I can't have 0. It always has to be a non-zero number. Okay, so now, which row I must copy because it will not change?
Row one.
Of course, yes. That will not change. It has to stay. Let's do this multiplication together. Ready? 1. So I know you are aware we are doing number 3. We're multiplying a row and by a non-zero number, and we're adding the result correspondingly to each and every entry in another row. Ready? So 1 times -2
Negative 2.
plus 2.
0.
Excellent. -2 times -2. I have to multiply everything. So it's -4. Positive 4. Positive 4 minus 1.
Positive 3.
Excellent. -1 times -2
It's 2.
plus 1.
3.
Excellent. 2 times -2 plus 4. Excellent. Well done. Row 3, please. 1 times 1 minus 1.
0.
Excellent. -2 times 1 plus 1. Excellent. -1 times 1.
Oh, hold on.
-1 times 1.
But wouldn't it be
-1.
1 times 1 is 1?
1 times 1 is 1 minus 1 is 0.
Right.
-2 times 1 is -2 plus 1 is
then we're adding
-1.
it to the third
Oh,
one,
yes.
sorry.
Yep. That's the
Okay,
key.
Okay, there we go. I looked at it wrong.
We did the same thing with row 2. Now we are doing with a different number with row 3. -1 times 1
-1.
minus 2.
-3.
Excellent. 2 times 1 minus 4.
Positive. -2.
Okay, what did we accomplish? A lot. This is done. Where is my next step? And I can't change that.
Your next step is to make that middle 3.
A 1. Okay, so let's analyze. Is there a way of making this a 1? Keeping in mind that I have 3 possible operations that are allowed.
Can you divide by 3 because 3 is 0, 3 equals 0.
Excellent. Excellent. I will divide both sides by 3. Or the entire row by 3. Excellent job.
So you can swap and place negative on the bottom and then
You could swap, but not with the top. If you
No, with the
swap,
second one.
yes, I completely agree. So 1, -2, -1, 2. Can anyone give us the second row?
So it'd be 0,
1, 1, 0. 0, -1, -3, -2. So now this is the target. We are happy because we got the 1 in the middle, but now I have to do my magic to make sure that these become 0. Which row will be used now? I have to use row 2 to determine these, to get those zeros. I have no choice.
right.
So it has to be row 2 multiplied by something and added to row 1. It must be row 2 and added something and added to row 3.
Row 2 be multiply
So
by
we are done with the row 1. The next step is row 2. What do you think the next step would be?
if we multiplied it by
The next step will definitely be row 3. So, yes, I'm ready. What do we multiply by to eliminate the negative 2?
positive 2.
Excellent. What do we multiply by to eliminate the negative 1?
I said it, so I meant 1. I was looking at it.
Is that okay?
Yeah.
Yes, any questions? Yes.
How did you get the numbers that are in the box? What did you do to get the numbers on this side of it, on this side?
Here?
No, over here on this side of the line. Yeah, like the three rows. How did you get the numbers?
Here I copied this one. Here I divided as I had. I divided both sides by 3. And I got this one. And here I just copied the third row. I didn't do anything else. So on the right-hand side, I explained what I'm doing from this step to this step, from this step to the next step. So all the information is right here. We have to put it in writing. We have to see it. Is that okay? Yes, that's all we did because we needed to obtain the 1 in the middle. Everything else got copied. But I cannot divide, pick and choose. I have to divide everything. Yes, awesome. Good, so then next step. So tell me which row do I have to copy this time and it certainly will not change.
Third row.
I haven't gotten to the third row.
The second one.
Exactly, it's the row I'm using. The row I'm using cannot change. I am using it. And this cannot be broken. This is done. No one can touch that. We're not going backwards. So, ready? 1 times 2 minus 2. 1 times 2 minus 1. Excellent. 0 times 2
0.
plus 2. Excellent. Well done. 1 times 1 minus 1. Excellent. 1 times 1. 1 times 1 is 1. Minus 3. Very good. 0 times 1.
0.
Perfect. Minus 2. Excellent. What did we accomplish? Exactly. Exactly. We have one more step to go. Maybe 2. What is my next target? One more time. I finished with 1 and corresponding zeros. With 1 and corresponding zeros. Now I'm here.
You're going to change that negative
Into?
to a 0. A 1. A 1.
How?
Sorry.
How? How?
Could you multiply another row and add it into it?
Never. Or 3 divided by negative 2. Exactly what we did before. Excellent. So 1, 0, 1, 2, 0, 1, 1, 0. I just copied. I'm not touching row 1 and row 2. I'm only working on row 3. So can anyone give us row 3?
0 all the way across, right? Or no, it's going to be a 1 and a 1.
Excellent. Can you already give us z? Can anyone already give us z?
Z equals 1.
Exactly. We don't have to identify it right now, but I'm sure you're anxious to get the answer. Good. So now finally I have to multiply row 3 by something and add it to row 1, row 3 by something and add it to row 2. What am I multiplying? So again, no one can touch these. Those are done. This is done as well. My target is this, and my target is this now. So what do I multiply row 3 by to get a 0 here, and row 3 by to get a 0 here?
Negative.
-1 in both cases. Awesome. Well done. So let's do this together, and this is indeed the last step. I'm copying what cannot change ever again. Ready? 1 times -1 plus 1.
0.
1 times negative 1 plus 2. Excellent. 1 times negative 1 plus 1. Perfect. 1 times negative 1 plus 0. All done. And now can anyone give us x, y, and z?
X is 1, y is negative.
Do I believe it? Oh no. 1, negative 1, 1. It's so easy to make a mistake in this Gauss-Jordan. This is the method called Gauss-Jordan. It's so easy to make an error. And if you do, don't try to find it. Start from scratch. It's so difficult to find the error. Okay, I go back to a system like 15 million pages ago. But that's the first problem. You've been warned. Sorry, my apologies, but that's what it is. First problem. So we had 1, negative 1, 1. 1, negative 1, 1, 1, negative 1, 1, 1, negative 1, 1. Let's do this together. 1 plus 2 is 3. 3 minus 1, check. 2 plus 1 is 3, plus 1 is 4. Check. Negative 1 minus 1, negative 2 minus 2, negative 4. Now I'll say yes. You will only have one problem like this. Of course. Okay, ready for the next problem.